Recording now. Okay. 4-6 concept guide, chapter 4, section 6. We're doing Cramer's rule. All right. Cramer's rule is another way to solve equations. First, we're going to start with a system of two linear equations. Cramer's rule uses determinants to solve systems of equations. Compare the process by solving the following system of equations by using elimination. Not going to do that. But I do want to point out that the coefficient for x in the first equation, 2, that's A. The coefficient for x in the second equation, 3, that's C. Coefficient for y in the first equation, 5, is B. The coefficient for y in the second equation, 4, is D. All right, you're about to see a lot of A, B, C's, and D's. That's where that comes from. And what those two equations equal, 24 and 22, that is E and F. So, Cramer's rule for two variables. The solution of the system of linear equations is given right there. All right, so we're trying to find x and y. All right, the denominator in Cramer's rule will always be A, B, C, and D, the coefficients of x and y. That never changes. The denominator remains the same throughout on Cramer's rule. What does change, though, is the columns and the numerator. So when solving for x, I'm going to replace A and C in the numerator with E and F. I like to call that the x column. Okay? I'm replacing the x column with the two solutions. So then for y, the x column remains the same numbers in the numerator and denominator, but in the numerator I replace the y column with the two solutions, E and F. All right, then to find your solution, you find the determinant of the numerator, determinant of the denominator, divide, and you get your answer. What's nice, though, is you only have to find the determinant of the denominator once. Another key to Cramer's rule is obviously the denominator cannot equal 0. First example. As you can see, for x, the denominator is 5, 2, 7, and negative 5. I like to call that my x column is 5 and 2. My y column is 7 and negative 5. Well, in the numerator, I'm replacing the x column with the two solutions, 13 and 13. Y column remains the same. All right, remember, in finding the determinant of a 2 by 2, you will find the difference of the diagonals. All right, so find the difference of the diagonals in the numerator, difference of the diagonals in the denominator. You get negative 156 over negative 39, and x would equal 4. All right, y, solving for y. Tyre, please stop filming me. All right, for y, the denominator remains the same. Numerator, the x column stays the same. We replace the y column with the two solutions, 13 and 13, what the two equations equal. All right, so again, I already know what the denominator is. It's negative 39. That doesn't change. So for the numerator, I need to find the difference of the diagonals. 65 minus 26 gives me 39, so y equals negative 1. My answer is 4, negative 1. Again, this all works together. If we graphed, the point of intersection would be at 4, negative 1.
Instagram, live stream.
All right. Sorry, I'm distracted. I put the U try up way too early. But as you can see in the U try, the denominator remains the same on both. We have the x column and the y column. The numerator for x, we replace the x column with what the two equations equal, 28 and 8. And for the y, when we're solving for y, replace the y column in the numerator with 28 and 8. Everything else remains the same. You should have gotten 4 and 2. Solving for 3 variables is very similar, just a lot more work. Let me get this all up here. As you can see, when you look at x, y, and z, the denominator remains the same throughout. When solving for x, you replace the x column with JKL, what the equations equal. When solving for y, you replace the y column in the numerator with JKL, what the 3 equations equal. And for z, you replace the z column in the numerator with JKL, what the 3 equations equal. And again, the denominator cannot equal 0. Alright, so when doing these, I did this first example with x. I replaced the x column with -1, -9, and 5, and I solved by using diagonals. And so I did -1 times 5 times -1 is 5. 1 times 3 times 5 is 15. 1 times -9 times -2 is 18, minus the diagonals going in the other direction give me 25 plus 6 plus 9. I did diagonals in the denominator as well, so I got 3 times 5 times -1 is -15. 1 times 3 times 9 is 27. 1 times -6 times -2 is 12, minus the diagonals go in the other direction. 9 times 5 is 1. -2 times 3 times 3. 9 times 5 times 1 is 45, sorry. -2 times 3 times 3 is -18. -1 times -6 times 1 is 6. Work that out, and that gives me x equals 2/9. Alright, when you're doing these, I do want you to solve for x, or at least one of the variables. What's nice is you now know that for x, y, and z, the denominator will be 9, no matter what. You don't have to do the denominator again. Alright, what's also nice is after you solve for one of the variables at this point, I will let you use your calculator to solve for y and z. Okay, so the way we will use our calculator for y and z is we need to make sure that we make 3x3 matrices set up like I have y and z right here. We already know that the denominator is 9, so you don't even need to set up the denominator. You can just divide each of these matrices by 9, or you can put it all the way in, either way you want to do it. So when doing this, I got screenshots of the calculators. Alright, so first you need to get into the matrix mode on your calculator, hitting second and then matrix. After you hit second matrix, that will take you to this screen. You're going to want to go to edit, and you'll want to edit the matrix to a 3x3, not a 2x2, a 3x3, and you want to enter in your numbers. Alright, you already know the denominator is 9, but you could do that for b as well and continue the process. 3x3 and put in the denominator. Alright, after you put that in, you need to hit second matrix again and slide to the math section. The math section will have an option that is DET parentheses. You need to hit that before you divide your matrices because you're finding the determinant of it. So you'll hit determinant, then you'll go hit second matrix again and go back to your screen that looks like this, and you'll put an A. You need to close parentheses. Alright, which is important. You need to close the parentheses, then divide it by the determinant of b. And that will give you your y. Do the same thing for z. But again, you know that b right here is 9, so you can just divide by 9 as well. After you do that, you will get y is negative 4/3 when you simplify, and z is negative 1/3 when you simplify. Alright, again, I want you to find x using diagonals or expansion by minors, but then y and z you can do in your calculator. Next we got the u-try. Go ahead and try and solve it yourself, but here's the solutions for it. Oh yeah, so the denominator is 0, and so if the denominator is 0, there's no solution. Alright, be prepared to work more problems like these next class. Thank you.